Hello, everybody. Good. I will take us into a different world. Low carbon fuels without biomass, sort of completing the picture. And a subtitle here, Welcome to the World of RFNBOs. Just a show of hands, has anybody heard this term before? Who's heard of the term RFNBO? Excellent, right. This really is going to be, you heard it here first. This is a term that actually has status in legislation and so on, though it's spelt out, and I'll reveal shortly. What I'm going to talk to is what RFNBOs are, why we're talking about them today, how ready are they, what vehicles are they suited to, what's the problems, what are the opportunities. Before I do that, very, very briefly, one slide, the perspective I bring to this is that of a strategic consultancy that works in sustainable energy and fuels and transport and vehicles. The LCV show is something that we've been to many, many times. It's fantastic to see how much it's developed over the years. I've actually spent all the morning talking about batteries, which is something that we've been involved in as well. And it sort of feels slightly hypocritical at one level to think, well, here I am now talking about liquid fuels and gaseous fuels. But actually, for the reasons that Penny set out earlier on, absolutely not. This is the other side of the coin for that bit of the transport sector, which is going to be very difficult to deal with through battery electrification. What is a RFNBO? It is a renewable fuel of non-biological origin. Sounds a bit turgid and a bit theoretical. Actually, it's an important concept, but more than that, it's actually real fuels that are, to some extent, being applied today. The reason that people are interested in this world of fuels is that whilst biofuels have great promise, and particularly as Katie was elaborating, and indeed Chris as well, there are sources of biofuels that are pretty sustainable, show promise for certain sectors. There are also some challenges with other flavours of biofuels. And then on the plus side, there are also sources of waste, in inverted commas, which can be turned into these fuels. But I'm talking here particularly about waste sources of electricity and waste sources of CO2. And that's the opportunity side of RFNBOs. Just as a PS, we've kind of, just to complete the picture, there are also so-called low-carbon fossil fuels. So there are waste sources of gas, CO2, that have come from combustion of fossil fuels, which can be subsequently upgraded into liquid fuels. I'm not going to talk about those today, but I mention them for completeness. Of course, they have a higher carbon footprint. The beauty of RFNBOs is they have the potential to be really zero carbon. And this is how. It's a family of fuels. It's not one thing. The thing they have in common is that you are using a primary energy source which is zero carbon, renewable electricity, in some cases pure sunlight. And in most cases, you go through a hydrogen step. I sort of set aside the ones at the bottom. They are at the very experimental stage, or the more experimental stage, I should say. The ones that go through hydrogen use that electricity to electrolyse water to make hydrogen. And then that hydrogen is combined with carbon dioxide in a process which is either catalytic, microbial, methanation or fermentation to make a fuel which is either a liquid or a gas, but which I think you can see, even as a non-chemist, you can see those are shorter chain hydrocarbons than the kind of, in most cases, than petrol and diesel, methanol, methane, and ethanol. Where it gets more complicated is where you can produce a so-called drop-in fuel. Katie referred to this earlier. Fuels which are chemically sufficiently identical to gasoline, diesel or jet that you can put them into an engine or a turbine with no so-called blend wall, no upper limit to how much you can put in as a blend. It can be the 100% fuel, and it'll behave like the fossil equivalent. Now, the other thing that this slide is showing us, there are a variety of fuels. There are some that are drop-in. There are a range of people around the world working on these. There's some examples of company names there, and I'll say a little bit more in a moment. But I do want to draw a distinction between things that are gaseous and liquid as well. So RFNBOs can be gaseous renewable fuels. They can also be liquid fuels. So it's a family, and they typically start with hydrogen. This is where they are in the TRL scale. So it's often when you talk about hydrogen that the hydrogen tends to be the thing which is regarded as early stage. In the world of RFNBOs, pure hydrogen is actually the most mature, the most developed. It's pretty much commercial. In as much as the picture shows, there are commercial electrolyzer companies who are producing fuels for use in transport. And I should stress, RFNBOs are only for transport applications. Methanol is also being produced at quite large scale. The picture you see there is of a plant in Iceland. This is an interesting one. They use renewable electricity from geothermal energy, so obviously renewable, to produce hydrogen. They also take CO2 from the geothermal vents. So quite high concentration CO2 comes out of geothermal vents. And they catalytically combine those to produce methanol, which is sold into the European fuel transport mix pool. Other products, routes to RFNBOs are somewhat less mature, and it tends to be the things that are the more liquid, the harder it is, and that's the scale that you see there. Why are we interested in this, and who is interested in this? Now, if you haven't seen the APC, the Automotive Council Technology and Product Roadmaps, they could be regarded as the kind of pre-reading for coming to Cenex LCV. But if you haven't, I commend them to you. They represent kind of distilled thought on the part of a large number of stakeholders. I was actually involved in pulling several of these together, and this one on thermal propulsion, so if you like, the future of engines. I think it'd be fair to say there was quite a lot of controversy in pulling this one together. But one thing that wasn't controversial is that bit that I've put in a red circle, which I don't expect you to be able to read, but it's the bit about fuels. And it says, essentially, from here till sometime 2025 to 2030 time, we've got diesel, we're going to use diesel, that's the main game in town. Of course, there are natural gas engines and some other things used in heavy duty, but essentially it will be a diesel story. But beyond that time frame, and obviously with the R&D work starting now, there is the opportunity, which is recognised by the vehicles and the fuels community, to co-develop and, if you like, customise engines and fuels together so that you get the best properties of fuels for engines and vice versa. And that's where RFNBOs can play a part, because, of course, you're not stuck with a crude oil which will cut into a certain way. You can, to some extent, customise these fuels. So there is interest despite the technical challenges. But let me talk about how much there could be. Let me start with the pictures at the top there. What you have there is a picture of the largest wind farm in the UK. That's an offshore wind farm in central North Sea, Walney Extension. It's about 660 megawatts. 200 and something turbines. It's a whopper. If the entire output of that wind farm, and this is obviously a theoretical exercise, if the entire output were dedicated to producing electricity that was then just fed into electric vehicles, it would run a fleet of around 850,000 vehicles for its normal duty cycle over a year. If instead you use that renewable electricity to make hydrogen, to subsequently make hydrogen alone, and you put that hydrogen into fuel cell vehicles, then you have enough energy to achieve the same distance as for 450,000 vehicles. If you turn that hydrogen into a liquid fuel, liquid diesel or gasoline type fuel, you have a further energy penalty of doing so, which means that you can only run 150,000 vehicles from that. Now, by that sort of energetic analysis, you might say, why on earth are we interested in RFNBOs? But remember, this is an energy-dense fuel, and it's potentially that liquid fuel might be reaching vehicles which cannot be served, for example, by the battery or potentially by hydrogen. Just some other things, sort of combing out of the sort of denser text below that. We've done scenario modelling to 2030, looking at the potential for RFNBOs, kind of considering how much spare renewable electricity there might be in Europe and what the ramp-up rates might be for plants producing these fuels. And whilst it potentially makes a contribution to the European transport fuel mix, it's in the low single digit percentages. That's still a lot of energy, but it's, this is not, as perhaps some people have been tempted to think of it, as a kind of panacea. We can do all of this with electricity. Let's not think about the alternative. Let's not think about anything else. Others, LBST DINA, German Energy Agency, have done analysis to 2050, and their kind of somewhat equivalent way of putting it is that, firstly, they do see RFNBOs as playing an important role in the fuel transport mix for Europe in 2050, in a highly decarbonised world. But that you need somewhere between 5 and 10 times the current installed renewable capacity in order to meet that need. So we're talking about very large quantities, as the headline on this slide says, of renewable electricity. And then the last line of that is the policy piece of this, because there is renewable electricity, and we've got that wind farm at the top is being built, but there are incentives in place for renewable electricity, and what policymakers are very focused on at the moment is making sure that we don't double dip, or in other words, we don't kind of cheat ourselves in the carbon sense and pretend that we've decarbonised our electricity system and decarbonised our transport system with the same electrons. So policymakers are very focused on making sure that RFNBOs are made with additional renewable electricity, i.e. electricity that would not have otherwise found a home. There is potential. There is an energetic penalty for going all the way to a liquid fuel, but it can make a contribution. And of course, there is a cost as well. This is analysis by others, but I think this is probably the neatest summary I could kind of put my finger on. What you have here is a series of RFNBO fuels, so methane, liquid fuels, which are roughly diesel-like fuels, and gasoline-like fuels. Okay, so that's the three bars. What you have in the stack, excuse me for walking. This first bit is basically your electrolyzer costs. The cost of buying and operating your electrolyzer. You can see it varies slightly between them. The significant one is this big blue chunk here. That's the renewable electricity cost. And by the way, that is the renewable electricity cost at 5 cents euro cents per kilowatt hour, which I'll say some more about at the moment. The rest of it is about the capex of the fuel synthesis step and other sort of other capital costs. But I really want to drill into the point about renewable electricity. Remember we said this is made with spare electricity, or waste in inverted commas electricity. 5 euro cents per kilowatt hour is at the very low end of renewable electricity costs at the moment in Europe. Industry on average pays about 10 euro cents, large industrial customers. I think I'm right in saying that the cheapest or the lowest cost electricity from PV in the Middle East is somewhere in the 2 to 3 euro cents range. So it's not impossible, but this is, you know, even at these numbers, it's quite a big chunk is that renewable electricity cost. And now here's the kicker. That's the current cost, around 500, of fossil diesel and gasoline. Now, of course, that's not an apples and apples comparison. That's a wholesale price to wholesale price. There's tax, there could be carbon pricing, and so on. But essentially, on an untaxed basis, you've got, you know, there is a hill to climb. Now, some of these costs will improve. This is a present-day analysis, but I kind of want to repeat the point that RFNBOs are not a panacea either in availability or in economic terms as they currently stand. However, they do hold promise, and this is something that is recognised by policymakers. And renewable fuels policy is a very complicated and somewhat devolved suite of policies around Europe, but RFNBOs are specifically included in European policy instruments that support low carbon fuels. They have specific support in a range of European countries, and in the UK they are treated as so-called development fuels. And that means that they could receive as much as £7 a kilo for renewable hydrogen. My colleagues, and I do stand on the shoulders of giants, I stress, in this field. I have some very clever and informed colleagues who work in this area all the time. They tell me that about £5 a kilo is probably the highest that hydrogen is likely to get given competitive pressures. But essentially, the short version of that is we do think that there will be renewable hydrogen coming into the UK market because of this incentive scheme for use in road transport. So let me summarise. Liquid RFNBOs are attractive as a means to provide an energy-dense fuel. They avoid some of the drawbacks of conventional biofuels, but there's an energy penalty for going all the way to a liquid compared with putting that electricity into a battery or going half the way to hydrogen. Drop-in liquid RFNBOs are less technically mature than the other ones. Volumes are constrained and are likely to remain constrained by the availability of truly additional low-cost renewable electricity. But they could make a useful contribution as part of a mix. And finally, their economics, whilst challenging at the moment, are quite generously or relatively generously supported in certain areas, which is attracting interest and is encouraging the development and commercialisation of some of these fuels. Thank you very much.